Hi everyone, this is a show and tell video for the homework assigned to lesson 24 of Paul Mcwhorter's playlist series of instructional videos entitled All New Arduino R4 Wi-Fi Lessons for Absolute Beginners, linked below. In lesson 24, titled Make a Push Button Switch with a Pull-Up Resistor, Paul introduces us to the push button switch. The push button switch, like any other switch, can be closed or open, but it's based around a spring. So you apply a pressure to the switch and it is closed. You release the pressure, the spring pushes back, and it is open. The push button switch allows us to provide a mechanical input to the Arduino, a digital mechanical input, an input that's either going to be on or off, yes or no, 1 or 0. In previous lessons, Paul had helped us to provide information to the Arduino via mechanical input using a potentiometer. That was an analog input. He also helped us to provide an input to the Arduino using the serial monitor, in which we could type our input into the Arduino via the serial monitor as text or as numbers. In lesson 24, we used the push button switch to turn on an LED. We pushed down, the LED was on. We released, the LED was off. The circuit that we used for lesson 24 involved putting a push button switch between the 5-volt supply of the Arduino and the ground. We then took a lead from the live leg of that switch and ran it to pin 12. Pin 12 is a digital pin. We set it up as an input pin, so it was able to take a digital reading from the push button. If we didn't press the push button, the digital reading came back as a 1. If we pressed the push button, the digital reading came back as a 0. A red LED was placed between pin 2 and the ground. Pin 2 is a digital pin. We set up pin 2 as an output pin, so it could send out information as either 1 or 0. Resistors were used in the circuit to protect the Arduino and to protect the LED from excessive current flows. So the homework that we were set for lesson 24 was to keep the same circuit that we were using in the lesson, but to change the sketch such that the push button switch was to behave as if it were a toggle switch. That is to say, you press the button, the LED goes on. You press it again, the LED goes off, toggling on, off, on, off. But there was a catch. The homework required the LED to change from on to off to on, when the push button switch was released. Now what that means is you press down on the push button switch, nothing happens. You release the push button switch and the LED changes from on to off to on. Press down, nothing. Release, change. Press down, nothing. Release, change. To solve this homework problem, I knew that I had to break the task into a series of little steps. The first step was that the whole circuit had to just sit there and wait for the user to do something, to press down on the push button switch. So that was step number 1, just wait for the push button switch to be pressed down. Step number 2, just wait for the push button switch to be released. That was step number 2. Step number 3 was that the Arduino needed to observe the current status of the LED. Was the LED on or off? That's step number 3. Figure out what the current status of the LED is. Step number 4, change the status of the LED. If it's currently on, turn it off. If it's currently off, turn it on. Then go back to step 1. In my sketch, I had 5 variables that I called out at the beginning of the sketch. But pin and myLED were the variables which controlled which pins of the Arduino I was going to use. So but pin was to control the push button and myLED was to control the LED. But val and LED mode were the variables in which I kept information. But val was the variable that I received information from the push button, and LED mode was the variable which I used to push out information to the LED, where 0 would be off and 1 would be on. DT is just delay time. To achieve step 1, in which the sketch is waiting for the user to press the button, First of all, I instructed the Arduino to do a reading of the butt pin and store that in butt val. If the user is not touching the button, then that value for butt val will be 1. I then dropped the sketch into a while loop, where inside the while loop, the only thing that was going on was a continuous reading from the button. 1, 1, 1. As long as the user didn't touch the button, the entire sketch was trapped inside of that while loop. As soon as the user touched the button, however, then that butt val would become 0 and the sketch would escape the while loop and move on to the next part. To achieve step 2, in which we're waiting for the user to release the push button, I used the while loop trick again. But this time, inside of the while loop, we were waiting for that butt val to become 1. As long as the user is holding the button down, the butt val is 0. As soon as the user releases the button, then the butt val becomes 1 and the sketch escapes the while loop. Step 3, determining whether or not the LED was on or off, was done by referring to the variable LED mode. LED mode was set up at the beginning of the sketch as 0, where 0 indicates that the LED is off. As the sketch ran, however, that value for LED mode would be swapping constantly between 0 and 1. So if the sketch looked at the LED mode value and saw that it was 0, that would indicate that the LED was off. And if the sketch looked at the LED mode variable and determined that it was 1, that would indicate that the LED was on. Finally, step 4, changing the status of the LED, was done with an if-else statement. The if-else statement instructs the Arduino to refer to the value for LED mode and then choose one of 2 mutually exclusive paths. If LED mode is 0, that indicates that the LED is currently off and the Arduino is required to turn it on, digital write high, and then change the value for LED mode from 0 to 1 before starting the program all over again. Alternatively, if LED mode has a value of 1, indicating that the LED is currently on, then the Arduino is instructed to turn it off, digital write low, and then change the value of LED mode from 1 back to 0, before returning to the start of the sketch again. So there you go, that's the end of my homework. Thanks, Paul, again for the fantastic product that you're putting out there, helping us all to learn about Arduino. I am Legend. Catch you next time.